Products are designed as a whole, not just individual components. This translates in CAD as the ability to easily edit parts at the assembly level. In this example, we have a solid edge assembly of a pulley system where we want to make changes to the width of the custom pulley because we are going to fit a wider belt. Of course, that means editing several other components also to suit. First of all, let's approach this as you would in most any other CAD system using history-based editing. After we place activate into the part file, you will notice the list of the features on the left. Since I need to make the pulley wider, we can easily select the side of the pulley to make the initial edit. We see there is an overall dimension of 35, which I can change to 55. That makes this easy, or does it? Because there are dependent features farther down in 3, this change has caused these features to fail. Now we need to go back and try to understand what needs to be edited first so we do not have failing features. Let's just start by editing the hub height first and change the 10 mm to 20 mm. Once this is done, maybe we can go back and widen the wheel as we did before. This appears though it worked. But another issue is the thickness of the inner wheel is now too wide. Let's select the feature and push it back from 10 mm to 20 mm. Now those edits were easy, but you do have to figure out which features to change and in what order. So back at the assembly, obviously the wheel is now wider, which means it's interfering with other components, and we have some internal pulse to deal with too. To edit these, we could continue using a history-based approach, but this proved to be time-consuming because we'd have to modify each part individually. Of course, working with history-based part, we could set up links so that the other parts would update automatically, but that also takes time. We want something instant that doesn't have the overhead of interlinking. Let's turn to Synchronous Technology. First, notice we're staying at the assembly level. From here, we can pick a face and drag to edit. Solid Edge is intelligent enough to know that there is a symmetrical part and that we probably want to keep it as such. But what if you want to make several edits at the same time? Let's see how this works by selecting multiple faces from multiple parts. Here we can modify not just 1 or 2 or even 3. But let's edit 4, 5, and 6 different aspects from 4 individual parts. And still, Solid Edge is automatically seeing that this design is symmetrical. So actually it's doing double those edits for us. Also notice how everything else is changing sensibly. Tangent relations and wall thicknesses, for example, are all being maintained. That's what we mean by one-shot multi-part editing. Looking good and very quick. Another way to make one-shot multi-part edits is by aligning faces. Again, all at the assembly level. For example, we will rotate this view so we can see the backside of these brackets. We can then set these two faces to be in line very quickly. To take this a further step, we can ask Solid Edge to just as easily snap all those coplanar faces to this back face. Job done. So there you have it. No more in and out of each part with time-consuming history-based edits as you go. Synchronous Technology in Solid Edge allows one-shot multi-part editing, accelerating your design.